Imagine driving your car tomorrow, and suddenly every single gear inside the transmission simply vanished. Everything would stop instantly. Most people never think about this, yet billions of precision gears quietly keep our modern world moving every single second. But here's what nobody tells you. Every perfect gear begins as an ordinary piece of steel with remarkable hidden potential. That transformation demands incredible heat, microscopic precision, and machines so accurate they measure thinner than a human hair. Some gears spin only once a day, while others survive millions of revolutions without failing under crushing forces. Think about this. One tiny imperfection smaller than a grain of dust can destroy an entire multi-million-dollar machine. Engineers spend decades mastering tiny details because every tooth must share enormous loads with absolute perfection. And this is where it gets truly extraordinary. Entire factories exist solely to perfect these remarkable circles of steel. Before the first tooth is ever cut, an incredible journey begins thousands of kilometers away beneath the Earth's surface. Every precision gear begins with iron ore, and some of the world's richest deposits lie beneath Australia, Brazil, and Sweden. Some mines produce or containing over 65% iron, making it ideal for premium engineering steel. Imagine a single haul truck carrying nearly 400 tons of ore in one enormous journey across the mine. The ore travels hundreds or even thousands of kilometers by rail before reaching towering steel plants beside busy ports. Inside the blast furnace, temperatures climb above 1,500 degrees Celsius, turning raw minerals into molten iron. That's nearly 2,732 degrees Fahrenheit, hot enough to completely reshape the metal's future. But molten iron alone isn't strong enough. Engineers carefully add carbon, chromium, nickel, and molybdenum to create alloy steel. What happens next surprised even experienced engineers. Tiny chemical changes create steel capable of surviving decades of punishment. Every batch undergoes laboratory testing, verifying chemical composition before a single gear blank can enter production. Most people never see this hidden beginning, yet every reliable gear depends completely on these invisible decisions made today. And now the steel faces its greatest challenge. In the next stage, ordinary cylinders become precision gears measured in microscopic accuracy. The moment has arrived. That ordinary steel cylinder now enters a factory where precision is measured in millionths of a meter. Powerful saws slice long steel bars into gear blanks within seconds, leaving bright silver surfaces still warm from cutting. Hydraulic forging presses and strike each blank with forces exceeding 2,000 tons, strengthening the steel deep inside. The heated steel reaches nearly 1,200 degrees Celsius, or about 2,192 degrees Fahrenheit. Next, CNC turning machines spin every blank at nearly 1,000 revolutions per minute, shaping perfect circles with astonishing accuracy. Long silver ribbons peel away continuously, filling the air with the unmistakable smell of warm cutting oil and fresh steel. But the smooth cylinder still cannot transfer power. It needs a precisely shaped teeth that make every gear extraordinary. That incredible job belongs to gear hobbing machines, where hardened cutters carve each tooth with perfect synchronization. The cutting tool rotates beyond 600 RPM while both parts dance together with mathematical perfection for several precise minutes. One tiny mistake here ruins the entire gear forever. Yet the most demanding step is still waiting just ahead. Now comes a moment that changes everything. Heat treatment transforms a carefully machined gear into an incredibly durable engineering masterpiece. Inside the furnace, temperatures climb to about 930 degrees Celsius, or 1,706 degrees Fahrenheit. Carbon atoms slowly diffuse into the surface, creating an exceptionally hard outer layer while preserving a tough inner core. Hours later, robotic arms lift the glowing gears directly into quenching oil, where roaring steam instantly fills a factory. You can almost hear the violent hiss as steel cools in seconds, locking remarkable strength deep inside every tooth. Grinding machines now remove only a few microns, creating mirror-smooth surfaces accurate enough for the fastest transmissions. Each grinding wheel spins beyond 3,000 RPM, producing a finish measured in tiny microns instead of millimeters. Finally, every sharp edge disappears during precision deburring, making each gear smooth, safe, and ready for exact inspection. Most people would call this gear finished, but experienced engineers know the hardest challenge has only just begun. The machining is finally complete, but this is where every gear must prove it truly deserves to leave the factory. Powerful laser scanners examine every tooth, measuring dimensions within 5 microns, nearly 20 times thinner than a human hair. Artificial intelligence instantly compares millions of measurement points against the original digital engineering model, without missing a single detail. Most gears pass immediately, but even a microscopic defect sends the entire part straight back for recycling. Modern factories often reject fewer than 1%, yet every rejected gear prevents far greater failures in the real world. But measuring dimensions isn't enough. Engineers must discover whether every gear can survive years of relentless punishment. Hydraulic test rigs apply thousands of newton-meters of torque, spinning gears continuously for hundreds of exhausting hours. Sensors constantly monitor vibration, heat, and noise because unusual patterns reveal hidden problems long before catastrophic failure begins. Think about this. A single gear inside an aircraft engine may operate flawlessly through billions of tooth contacts during its lifetime. Even with advanced automation, experienced technicians still detect subtle sounds and vibrations that machines occasionally overlook. That blend of human expertise and cutting-edge technology creates gears trusted in cars, aircraft, wind turbines, and even spacecraft. The journey doesn't end inside one factory. Precision gears quietly power almost every modern industry across the entire planet. Every year, manufacturers produce tens of billions of gears, from tiny watch components to enormous mining and marine transmissions. Together, the global gear industry generates well over $100 billion in annual economic value. China leads global production, followed by Germany, Japan, the United States, and Italy, each known for exceptional engineering expertise. Millions of skilled workers, engineers, machinists, inspectors, and technicians keep this remarkable global supply chain moving every single day. Did you know? The earliest wooden gears appeared thousands of years ago, helping ancient civilizations lift water and grind grain. 50 years ago, skilled hands performed nearly every operation. Today, intelligent robots complete many tasks with incredible consistency. Did you know? Modern electric vehicles still depend on precision gears, despite using far fewer moving parts than traditional engines. Did you know? The largest industrial gears can measure more than 10 meters across and weigh hundreds of tons. Over the next decade, artificial intelligence, digital twins, and smarter factories will redefine how the world's finest gears are built. But before these gears begin powering the world's greatest machines, one final chapter remains, and it's more meaningful than you might imagine. After thousands of precise operations, the journey finally comes full circle. A simple piece of steel has become something extraordinary. Every perfectly shaped tooth carries a work of miners, metallurgists, machinists, engineers, programmers, inspectors, and countless skilled hands. Without these silent machines, our cars, factories, aircraft, ships, wind turbines, and even spacecraft would struggle to move at all. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.